Hello, and welcome to another episode of Amiga Retro. Today we're going to be looking at a plethora, almost like an invasion, of Amiga 500 internal, so it's concealed, and neat and very portable, Amiga 500 accelerators. Or is it accelerators? You decide. So we're going to take a look at the ones that I have purchased over the past, and we will end this video on a conclusion of what I believe, at least to me, is the best internal accelerator for the Amiga 500. So let us get underway, shall we? So the first one we'll take a look at quickly, and this is not going to be an in-depth detail of how everyone operates, except for, of course, the last one, which I'll show you, but basically an overall of what this is. This is the Terrible Fire 530, so the TF 530. It was the first available one. And if you're not familiar with Terrible Fire, he does Atari and Amiga hardware development, especially for these accelerators. There's an 030 with 30 CPU here and an FPU. Basically, like I said, for the Amiga and the Atari computers as a CPU accelerator, and they are open source. So what you'll find a lot is, like right here, you'll see this one's actually from the amigastore.eu. So what it does is some people produce the circuit boards, and then all you have to do is populate them with all these surface mount components and the sockets and the CPU and all the other fun parts. And they all have an IDE interface as well. This one has the standard 40-pin IDE interface. That's why I have to get external power to it from the card, which is fine. But that's basically what this card is. So this is the first iteration or version of it. So this one is the TF 530. Now the only complaint I have about this card is it only has 2 megabytes of memory. Now that's okay. WHD load games, if you're kind of into that, which most of these systems are going to be used for, you're kind of pushing it. Oh, my fridge is turned on. Let me turn that off, shall we? Somewhere. Sorry about that. As long as I remember to turn it back on so not everything melts in the freezer. Okay, but I digress. Anyway, so the where was I? Yeah, so basically this card here is 2 megabytes of memory, which with WHD load may not be enough. Even if you have an Amiga 500 Plus, you have 2 megs of chip and you'll have 2 megs of fast RAM that this board offers. You're still kind of pushing it. You might have some issues, but my main complaint about cards that have low memory, there's 2 reasons. The main one is to speed these up. Now, not necessarily the processing speed, but the interface, the OS component, so they get a snappier, more responsive feel. You want the some kind of map rob function. So basically, you want the OS to be stored into RAM, and of course, it gets relocated. And instead of using it, going onto the 16-bit bus to access the Kickstart ROM, it'll be in RAM, which is 32-bit, and it's much faster. So if you do that, the average ROM is 512K, let's say, or 256 if you're running 1.3, 512 for anything from 2.0 and up. And but what happens is, of course, now you're down to 1.5 megs of RAM, so that can cause issues. Now it is a full-blown 030. So you can use a map ROM function or the MU libraries to remap the ROM. But other than that, it's a nice card. It's very stable. It runs at 50 megahertz, even though the CPU itself is clocked. It's on the silk screen is at 40. It's overclocked to 50. It runs just fine. Yeah, everything seems to work really well. And I believe, if I take a look at the processor, yeah, right there. If it can focus. Yeah, it's a full-blown 030, so you can, as long as it's not the EC variant, which these don't come with, you can use the map ROM function. Because you have an EC version of any of the processors, they don't have the MMU. The MMU is required for the map ROM function. Now, some boards that are made that don't have an MMU function, let's say a straight 68,000 or the 020 or 030 variant, they can get around by actually having additional firmware on the board that will map it itself. The Blizzard boards have done that, and there's a lot of other boards that do that. But this one particularly doesn't have that function, so it uses the either the CPU command from the OS 3.1 or 2 or whatever to map it, or you can use the MU libraries off of AmiNet to do the same functionality. Anyway, I kind of rambled on a bit there. I am sorry. So what we're going to do is, so that's the Terrible Fire 530, which I'm pretty happy with, but there's just not really enough memory for any kind of serious extended operations of this card. So that's the first version that I purchased. And the second one that I bought, sorry, my camera does not know what it's doing. It's confused almost as much as me most times. This here is just the CPU locator here, or sorry, relocator, so you can, have it not interfere with the components and other stuff. So it basically relocates where it sits, because it will sit like this in the computer, and it kind of gets it out of the way of the Kickstart ROM, which actually fits kind of right in here. So it clears that, and it works just fine. Let me reposition this. So this is the second version that I purchased. It's the once again from the AmigaStore.eu. It's a full-blown 030 again with FPU. This one has 4 megabytes of RAM. So this is the Terrible Fire, the TF534, and it has, without removing that, 4 megabytes of RAM, and that's pretty good. And it's got the IDE interface right here as well, so you can hook up a compact flash card, SD card, whatever like that. Same idea goes for it. Either the CPU fast ROM command from the OS, everything but 3.1.4 doesn't support that, so you'll have to use the if you're using that version of the Kickstart, you'll have to use 3. What do I call it? I don't remember. You'll have to use something. Yeah, you'll have to use the MU libraries off of AmiNet to get this to use the map ROM function. And I strongly suggest it. Like I said, it won't speed up the computational speeds of the CPU, but it makes the OS much more responsive. Screen draws, screen switching, opening up icons on the workbench, all of that stuff will work really well. So I highly suggest that, and I always use it. So once again, it's not bad. So if you use that, you're down to 3.5. It's not a bad card, but a lot of people wanted more memory on these cards than just 4 megabytes. And it kind of makes sense, because you can buy like 68,000 accelerator cards that are overclocked that come with 8. So you have an 030, why 4? And that's where the other card comes in. Without tripping over the tripod. Sorry for the camera, it just really doesn't know what to do with this keyboard. Okay, especially when you remove stuff that it was focusing on. Okay, this one here is the Terrible Fire, or TF 536. Now what's nice about it, it comes with 64 megabytes of memory. More than enough. You can map ROM this and have lots of extra memory left over, like more than you need. Really good. The only problem with it that some people might have, there's no FPU. Under here, this is just the compact flash adapter I have, but under here there's the RAM chips and stuff. There's no FPU at all, just the CPU only. So that's the lineup of the Terrible Fire cards actually, but they all run really well. So the TF 534 is pretty good. Definitely the 536 if you don't want an FPU. If you're if you don't really need an FPU, which a lot of times you don't. But, that could be a deciding factor of not to get this card. This is the most recent iteration right here. So that's the TF 536. Now my latest acquisition is this. It doesn't really actually have a name technically. It's made by TK, so it's a 68020, but EC020, so no MMU. And the card's nice. Now it comes with 8, I think you can map 9.5 megabytes of memory roughly on this card. I like it. It's kind of nice. It's got like the standard 40-pin IDE on it. It's got some other like an LED. You can like a hard drive output on it as well, right here. If I can get it on the camera, yeah, right there. So it's got some nice features, but it doesn't have a map ROM function on the board, and unlike the terrible fire cards that have a full-blown 030, remember what I said, this is an EC020, which was the same, actually a CPU that's in the 1200. You can't use the MU-libs libraries with this because there's no MMU. It won't work. That's what the MU, it's memory management unit libraries you get off AmuNet, so it cannot map the kickstart to ROM at all, and there's really no way to do that, because on this card they didn't implement it in the firmware to do it, so you're kind of out of luck. It's okay, it's faster, it's like I said, it's, than the stock, the 68,000 that's in the 500, but the snappiness of the GUI isn't quite there, so there's really no way around that unless he makes a new revision of the board. So I shall go on to the next one. This here is the Witcher 500i. Now it's a overclocked 68,000, which is right here. With you can use a 72-pin SIM module, up to 8 gigabytes. Now this thing runs okay. Now remember, it is a 68,000. You're not going to get blazing speeds out of it, even though it is. You can overclock it up to 50 megahertz. It's probably better around 25 in this version of the board. Now it's nice. It has the ID interface. It's got the LED like hard drive access light on it if you want to use that. All of that fun stuff. And actually, if I orientate it the way it will mount on this computer, it's not a bad card. Unfortunately, if you want to overclock it beyond 25 megahertz, that's the one problem. It's not very reliable. Now it's going to vary. It's like they call it the silicon lottery. It all depends on the chip that you buy. Unfortunately, they don't come with the 68,000 CPU, and this is the 68HC00 variant, which is the one that one with 3 zeros at the end. Oh, sorry, let's try it again. So this has the 68HC 000 variant, which is the low power, low heat version, because they kind of go hand in hand. But you have to buy them yourself. I think it's because they're to be ROHS compliant. There can be no lead on anything that they sell, and of course these chips are older. They don't make them anymore. They have some lead on their pins, so you have to buy it yourself. They're easy to get on the internet, and they do recommend the HC version over the regular, because you can buy these just as the 68,000. These will overclock better. You can get these at 20 megahertz, so if you want to overclock it to 50, you have a better chance, and they run cooler anyway, so you won't have heat issues. It also has an SPI port you can use, which I don't, but it's pretty full featured. But the main problem with this board I don't care for is this. Now it's nice that it takes 72-pin SIMs. Its compatibility is horrible. You can set a jumper to use either dual-sided or single-sided SIMs, regardless of what I have tried, and it doesn't make really any difference. You might get 2 megabytes, maybe 4, sometimes 8, then it may not be stable. So I wouldn't really recommend that for this card, just because it's, like I said, it's got really bad, or it has issues. But the good thing about this, it does let you map the tool that it comes with does let you map the Kickstart ROM into memory, which is quite nice actually. And it does speed things up quite a bit. So we're going to actually show you what I have in this computer. Let me zoom out here. I will take the top off carefully. There we go. So currently I am running, if I get this out of the way, and we'll move it in down here. I will zoom in, and there it is, or not. There, it's better. So this is actually the Witcher, which is made by 7-bit, the same as the 500, but this is the Witcher 508i. This board I like a lot. Now it comes with, you can map about 11, I think 11 and a half megabytes of memory for use, which is nice. And of course you have your compact flash here, and there's your CPU. Once again, you have to purchase it. It doesn't come with it. You have to buy it yourself, which is no big deal. They're quite available. And like I said, get the 68 HC 000, and hopefully find the 20 megahertz version. It gives you better opportunities at overclocking. Same idea. It's got the LED support for for turning on the for the LED indicator for the hard drive access. Now, the only thing about this one that's a bit off, or not off, but it's a bit different, it requires 2 connections to the motherboard. Now, oops, sorry about that, if I can get this out of the way. Now, in my case, I managed to find the points here on the motherboard. I kind of ohmed them out. There's a connection that's required from the CIA chip, and down here, Gary. And it's in the manual. They use like those, they have the ends like here, but they have those spring clip ends that kind of clip onto the legs. And I'll show you a diagram of that in a video of the actual, the pins they go to. Now I prefer in a more permanent connection, or not permanent because these do come off, but more of a stable connection. Because I haven't had luck with those, they just pop off all the time. Or at least for me to do. And so I can remove that and just have it stock again. It doesn't bother anything. But this will even map like 1 megabyte ROMs. I haven't tried 1 megabyte ROMs with the other boards, but this will actually do up to 1 megabyte ROMs, and it maps them. This runs really well, and unlike the 500i, this the memory is right on. I think that's a chip there. Is right on the board, so you don't have to worry about compatibility issues between 32-pin. Sorry, I keep saying that 72-pin SIMs and all that fun stuff. So yeah, that seems to. And to be honest with you, the reason why I saved this last, this is the board I want to leave in here. It works really well. It's great for games. It keeps it as close to like the stock CPU as possible, just with a slight overclock boost. And of course, you have the hard drive controller as well. So I will show you what this thing looks like in operation. Hello. As you can see, we are now at the Amiga workbench with almost 2 megs of chip RAM and almost 9 of fast. So what's really neat about this software, magic. I always kind of like that about the Amiga. I'm not sure why, but anyway, screen dragging. The Witcher 508i does have its own config tool to set up all of this fun stuff. So I will show you if I go into prefs, and you notice it opens up the icons really fast. So it does having fast ROM in memory, like for the card to use, like the map ROM function, works really well. It speeds up a lot of the OS functions, especially screen drawing and all that fun stuff. So here's the tool here. As you can see, it's using the MC, it's Motorola, the 68000. It won't show the HC because that's not defined in the chip ID. It's just the HC is just a lower power variant of the original 68000. And as you can see here, it's running at 50 megahertz. I have the C0 RAM enabled. I can also add an additional 1.5 megabyte chunk by using the the A0 RAM as shown here to give, like I said, the additional 1.5 megabytes of RAM. The map ROM function is on. Now, if I turn this off, it's going to reboot, and of course I'll cut the reboot phase out. You'll show the difference it makes. So first thing, it doesn't make a difference as far as sysinfo is concerned, because if I run it right now, it identifies the CPU. Of course, there's no FPU, all that fun stuff. Let's click on speed, wait for the results. Okay, it's not bad for 68,000. It's actually running at 3.82 MIPS. Of course, you don't have any M-flops because there's no FPU, but according to this, it's running almost 7 times faster than a stock 600/A500. So it's not too bad. Nice quick, nice good speed boost there. If I go to drives and do a speed test on DH0, which is of course the SD card, Wait for it. And not too bad, 2.2 megabytes per second. So that's not bad at all, especially for, even though it's overclocked for the for this board, for the 68,000 CPU. So what we're going to do is we're going to run these tests again after I disable the fast ROM. So one moment, quit that, close all of this fun stuff. I'm going to turn this off. It's going to want to reboot in Polish because it's kind of weird that way, but I'm pretty sure that's what it is. And did that actually reboot? Maybe I didn't need to reboot. Let's try it again. So I'll know when I can already tell the system has slowed down a bit. So actually you don't need, it does need to reboot when you start changing the memory. Like if you want A0 or C0 RAM, it will force you to reboot, but it didn't seem to do that. So I guess it just went back to, in real time, to the ROM on board. So let's try this again. So when I open up the system, you can see how much slower the icon opening is. Yeah, it makes it doesn't seem like a huge difference, but enough. So we're going to run you can even see it when I close the windows, it's a bit more, the redraw takes a bit longer. Let's go back to sysinfo again. Okay, if you do the speed should be roughly the same, because it doesn't really, if the map-rom function doesn't really function to speed the processor. It's pretty close to what the previous value was. But you'll see when I go to drives, I think we got a speed around 2.2 megabytes per second last time. Let's see what happens. Taking longer. Look at that. We went from 2.2 down to 850. So there is my case in point about you gotta get that kickstart ROM into memory through a map ROM function. Yeah, it made a big difference. So 3.74. So let's just quickly go back. And as you can see, we're roughly the same speed. The kickstart function doesn't, like map ROM, doesn't really affect the speed, but it does affect the OS part, how fast the OS accesses components of the computer. So let's re-enable that back again. I always have a habit of closing all my windows. Oh well. Okay, we'll turn it back on again. Okay. And like I said, you can already see it's a lot snappier when, let's say, open up a window and close it. Yeah, for sure. So if I go back into prefs, I mean, that's a lot quicker. And we'll go back to, where are we here? Sysinfo. Don't need to do the speed. The speed was similar last time. I think it was 7.62 or something. Yeah. I mean, it's not much to, the MIPS changed. I think it was 7.9 last time. So it doesn't really make any difference there. But if I go to the drives again, we should be back to our 2.2. Shouldn't take nearly as long. There you go. I couldn't even finish my sentence. Definitely a big difference. But I'm just surprised how well the Wicker 508i, its ID interface is just amazing. And it's super fast. I see some 030 cards, even with the map ROM function, not as quick for basically, grabbing icons and data off of the drive, like basically the hard drive access.
Hello. I just want to go over some interesting modification I did to this, and this is, like I said, once again, like all the modifications I tried to do, they're reversible, so they can be removed, and the computer will be pretty much back to stock. So you'll probably notice I have this wire here attached to one of the pins, which I soldered on to one of the pins here on this compact flash card, because this does have an ID interface. Now it does have right here the an LED output, but I wanted to use the floppy disk LED on the keyboard to show the flashing, indicating hard drive access, or in this case compact flash. So what I've done is, and there's a modification I did, it runs to, if I can zoom in carefully, right there, focused. Basically I have a resistor and a diode in here that connects to the base of the transistor. Now this is the bub board, so I don't have to take the board out to undo this. It's just I tacked it on with some solder to where the resistor joins at the solder pad on the board, because they're dual plated on both sides. But anyway, So it's connected to the base of this transistor and one of the other resistors that comes from the signal, which is the in use for the floppy disk, and it will turn on the basically it triggers that to turn on the LED on the keyboard for floppy LED for hard drive access. And it's a really simple circuit. I'll show you the schematic on that and explain it later. And like I said, you can remove it at any time. It's just tacked on the top. You can remove it, and it works best. You can actually see what I'm doing. It works best with the compact flash cards. If you use the SD card variant, it's okay, but I find the LED is a bit is partially on, so it's kind of lit but dimly without hard drive access, but it does flicker. But it works best if on these cards. Like I said, this the circuit I made over here is not 100%, but it works really well with compact flashes. So with the SD cards. And if I do use the output from here, it has really odd behavior. Because you could hook up just an LED here and put it through the case or something. But if I want to use the the LED on the keyboard for the floppy disk access to flash with this, it actually does the opposite. When it's off, the LED will be on all the time. When it has hard drive access or compact flash access, it will shut off, so it'll flicker. So it kind of does it reverse, which is kind of annoying because when it's not accessing, the LED will be on all the time. So that's not a good idea to use that unless you just go to a dedicated LED. Okay, excellent. Just wanted to show that to you, and I will be right back with the rest of the video.
So right here is a simple diagram of the circuit that I created to make use of the floppy LED as a hard drive access LED. This circuit here, which simply is composed of a diode and a current limiting resistor, is what I added, which you saw in the heat shrink, which I attached to this point here between R504 and Q1, which is on the Amiga motherboard. So I just basically join this connection with a nice clean tack of solder. And the good thing about that is if I decide to remove this in the future, I just simply unsolder it and it's as stock as possible. So this transistor and resistor are, like I said, on the motherboard, and they control turning the transistor on or off, allowing power to flow between collector and out through to the emitter to basically turn on the floppy LED whenever it's in use, as the signal suggests, the MTR0 signal. So basically what we're doing is we're just injecting a signal here at the base of this transistor, which basically turns it on and off using pin 39 of the, in the example that I showed, the pin 39 of the compact flash adapter. Now the compact flash adapters work best. SD cards will work fine, but I find that the LED is slightly dim when it's off, as in no hard drive access. So it's not too bad, but it doesn't work well with the dedicated LED outputs. Let's say on the board that I showed you, the Witcher 508i, or other ones I've tried with. Basically it actually works in reverse. The LED is on all the time unless there's hard drive access, and then it flickers. So it will flicker somewhat during hard drive access, but stay on when it's off, which is not desirable. So I really recommend using this, and it works flawlessly with the compact flash cards, and if you don't mind if the LED is slightly dim, with the SD card type interface boards. So just a quick rundown of what I've done is it's basically acting kind of like what the signal does. It generates a signal, but I tacked it in here right to the base. That's the 4.7K resistor, which is the exact same value of 504 on the motherboard. So how this will work is when the way the PNP transistors function is they work on a differential current. So basically the collector is tied to 5 volts, and it senses anything that's either above by 0.7 volts, above 5 volts, which won't happen because it's a 5 volt circuit, or anything that's below 5 volts, so basically 3.4 volts or lower, the transistor will turn on, basically tying the power, which comes in on the collector, out to the emitter, and then powers the floppy LED. So what's going to happen is this will go slightly low when it's accessing, enough to turn on the transistor, and thus it flashes. The reason why the diode is here is to prevent feedback in the circuit basically going into this part. Basically what it will do is You don't notice it unless there's a floppy disk in the floppy drive. And even though the drive isn't accessing, you'll hear the motor, and that's what that is. That's the motor signal. Will kind of flutter because it's getting pulses from the controller here turning on the transistor. So this stops basically what diodes do. It allows current or voltage to go in one direction and one direction only. So it basically blocks the power, or sorry, the voltage coming from the compact flash card from triggering the motor during operation. So that's how that comes in handy. So that's nice. And that's pretty much how that sort of circuit works. It's pretty simple, and like I said, the beauty of this is it can be removed at any time, because that's the one you saw that was in the black heat shrink. It was just the diode and the current limiting resistor connected to pin 39 and tacked onto the point between resistor 504 on the motherboard and Q1.
So I've rebooted the computer, and you will see the hard drive access light. There you go. Starts doing hard drive access things. And of course, if you use a floppy disk as well, it's going to light up, and they'll just be lit up for one or the other, or both simultaneously. But it works really well, and I'm quite happy with that arrangement. Like I said, it's not perfect. It works best for certain interface cards over others. So your mileage may vary. Hello. Oh, too close. There we go. Just wanted to show you how to. This is the 40-pin compact flash adapter. So if you want to connect the LED pin 39 for the circuit that I showed you on how to get the LED on the Amiga 500, the floppy disk LED on the Amiga 500's keyboard to activate with hard drive access, it's not too hard to do. Try to get a pin similar to the ones that are here for the IDE header, because they're pretty robust, they're a lot thicker. And all I've done is on pin 39, if I flip this over and get that in there, is I just soldered it like that, sticking out. Of course you have to be careful not to keep hitting it by accident when you're installing it, but it should survive the install process good enough. And it works really well that way. And like I said, if you don't want to use it again, you just have to unsolder it, and then it's done, right? And that's it, actually, pretty much. And okay, we'll go back to the rest of the video. Okay, and here is the 44-pin compact flash adapter versus the 40-pin I showed you previously. This is just one of those jumper wires. You can get these, comes off like so, and which goes to the circuit I made with the resistor and diode there, and then connecting to the, you can see that, yeah, to the solder pad there on one of the resistors, which is plated through, so it makes a good connection point. But anyway. So this one's pretty ideal, pretty simple, I should say. If I can tilt this up to look a bit better. Yeah, I've just soldered it pretty much. Tacked it on top of pin 39, which is right there. So if you do the same thing, you'll get the same result in combination with the with that circuit right there. So excellent. And that's pretty much it. And like I said, all of this is reversible. You just unsolder it and you clean it up, and it's like it never happened. So that is how that's done with the 44-pin compact flash adapters. And that pretty much wraps up the video. I know I was a bit long-winded at times. I apologize for that. It's kind of hard to explain sometimes. But other than that, like I said, I hope you liked the video. Like, share, subscribe, all that fun stuff. And that's it. I will catch you next time.